Okay, we are ready today to do a graph in Excel. We're going to take some data and we're going to plot it on a graph, and we're going to use technology to do it. No more pencils, no more books, no more teachers' dirty looks. Okay, we are going to plot a distance versus time graph, which is very typical in physics, science courses. But the skills that we're going to be using here can apply to any graph. Any two variables that you want to put on a graph, you can do this way in our good friend Microsoft Excel. So what we're looking at here is the final graph that we're going to make. We have the data on the left, time measured in seconds, distance measured in meters. We're going to plot these two things, X and Y, on a graph. We are also going to add a trend line or a line of best fit, and we're going to add an equation. The program is going to do all of this for us. We just need to play around with some settings. Okay, some notes on terminology for Microsoft Excel. If this is one of the first times you're using it, a lot of this will translate to other products like Microsoft Word, PowerPoint, if you use those. To start, at the beginning or at the top of the program, we have a home, an insert, draw, all those different commands. These are referred to as tabs. We can click on a different tab to get different functions. Notice how the pictures or the functions change with each tab. What we're looking at there, where it says themes, colors, or in the home tab, bold, font size, color, all of these tools are located in what's called the ribbon at the very top. It's the same thing in Word and PowerPoint. We can see that. So a lot of these tools show up in the ribbon. Another thing to consider is when we click on a graph, we also get a command box on the right hand side. That's format chart area with some options there. So sometimes we will see that. The tabs at the top get specified if we click on a chart or a graph, and we can see that in green we have chart design and format. Two new tabs show up when we select the graph. So we have options there as well. So it seems like there's lots of different places to look, but really when you're trying to do something or change something, it's the top, ribbon, tabs, or something on the right hand side. Let's get ready to begin making our graph from scratch. So I'm going to scroll down, and we can see that we have a blank space filled with a bunch of these rectangles, these boxes. Each of these boxes are referred to as cells. That's why the program is called Excel, because they have these little cells. We also have columns that have letters, A, B, C, D, and we have rows that have numbers. The selection that you can see here outlined in green is cell B25 that you can see indicated on the left there. To begin drawing this, I have to point out, for some reason, it's not a good idea to start putting your data in cell A1. I don't know why, but I tried this before and I couldn't get my graph to work. So avoid using cell A1 if you're going to start putting your data there. Notice how my data is in column B and C, and everything worked out fine. So you should do the same thing. The other thing to note is I am using the desktop version of Excel on my MacBook, my laptop. A lot of these tools, buttons, whatever, might look a little different if you are using Windows, for example, or if you're using a mobile device. So some of these commands may be in different places. They might not be there at all. So bear that in mind, please. So I'm using the desktop version of this program. So to begin, we see just a blank page, a blank worksheet indicated by the another tab at the bottom. I have other tabs open in my one program, and so I can make different sheets. I can make a graph sheet here for distance versus time. I could create another one for something else, voltage versus current, whatever I want. Create a blank sheet. I'm going to start in cell B25 just because I already have stuff at the beginning. And we are going to put in the title of our first variable, which will be time. That's our X variable. When we make the chart for this data, the X variable needs to go in the first column. We also want to put up the units that all of these will have, which is measured in seconds. So when I put numbers underneath this title of time, I will know that each number represents X number of seconds. Looking at the source data, that you also have the same data that you will be graphing, the time just starts at 0 and increases by 1 up to the number 4. To put that in, I simply type 1 and then enter. And when I hit enter, it brings me down to the cell below. 1, enter, 2, enter, 3, enter, 4, enter. And I've just input my data. Simple as that. For my other data, I will indicate that it is distance, and I will put the unit of meters underneath. You may want to just select Command C or Control C for copy, and then you select the cell, and when you Command V or Control V for paste, it puts the data in the appropriate order, right? With the different number of cells. It doesn't put all my numbers in one cell, it puts them in the 4 cells that I want. So I have a time value of 4 seconds with my distance value of 23 meters. Now so putting the units in the title allows me to have just numbers without units getting in the way, making it look cluttered or messy. It's very easy to read from this chart. So I've made my chart. If I wanted to format this, I could add a border, for example. So I could select from the borders menu on the home tab, and I could just put an outside border. So now my chart is outlined in black, just so I know that that is all my data. But now the important part, adding a chart or a graph. In Excel, they refer to graphs as charts because there's many other types of charts that you can do. To do this, or to find that menu, we go to the Insert tab, and then we go to the Recommended Charts tool in the ribbon for Insert. You notice that you can see images of other different types of charts or graphs that you can select, but it's better to do the recommended. For some reason, the formatting is easier to deal with when you select recommended. First, we will select all of the data in our chart or our table. I think I've been calling it a chart. It's a table. This is a data table. We select recommended chart, and then we have options to pick. Notice that, once that goes away, notice that the image you see here is a preview of what the chart will look like. So we do not want a column, we do not want a bar, we do not want a pie, we want a scatter. This is like the graphs that you were drawing in grade, that you draw in grade in math class. The type of graph that you're drawing in math class is in Excel is a scatter, called a scatter plot. Notice the difference. I know it's small, But see how you can see the individual points on the scatter plot, whereas a line graph does not show us the individual points. A line graph does not give us the information that we want, so we select scatter plot. This is unique to Excel. I don't know if you've heard the term scatter plot before. This might be unique to Excel and graphing software. We select this chart and it inserts our graph. We need to format it now because this is not good enough. We have the graph, but we cannot stop here. We need to change and add certain features. The first thing we will change is the graph title. Double click and select the text, and we will call the graph distance versus time. Simple as that. The reason is because distance is one of our variables, time is the other. Distance is our y variable, our dependent variable, so that goes first. Distance, and then versus time, our independent or x variable, comes second in the title. In the table, time goes in the first column, distance goes in the second. Next, we want to add labels to our axes. We can go to Chart Design, and we can go to Add Chart Element. And then from there we can select Axis Titles. We will pick a primary horizontal, and we can see it appear on the bottom, and then we will select primary vertical. That shows up also. Double clicking the text box that shows up, deleting the filler text, and putting our title, time, in seconds. We know that the x-axis is time because we put time first in our table. Excel automatically plots the first column in the table along the x-axis. We will then change the title of the vertical or the y-axis to distance. And we are including the units for both of those axes. The distance is written vertically, which is totally fine. We are allowed to do that. We do not need to change that formatting. From here, our graph is looking pretty good. We only have a few more things to change with it, and that reflects the data itself on the graph. We do not want connected lines showing us how each point connects to the other. The only thing we're interested in this example is a line of best fit, which we do not see on the graph currently. These individual lines are just basically connecting the dots between each data point. Clicking on the line itself, you should see 4 small blue dots surround each data point. That means we've selected the data series itself, and on the right-hand side of the page, Format Data Series should show up. We select the bucket menu, fill and line, and under the line menu, sub-menu, we select no line, and the connecting lines disappear. From here, once we've removed the connecting lines, we want to add a trend line or line of best fit. In the Chart Design tab, we go to Add Chart Element, and at the bottom, we add the trend line. We select linear, and now we have a dotted trend line, not connecting the dots, but showing us the line of best fit. Then, selecting the line itself, we should see the blue dot at the top at the right and at the left of the light blue dot of the dotted line, the trend line. And we should see Format Trend Line on the right-hand side of Options. We select the Options menu here, what that looks like a little bar chart, and we can see that we have our linear selected. And to add an equation, we select this option from the bottom, Display Equation on Chart. We can see that a text box appears that has the equation in it, and we can move it wherever we like on the graph to make it easier to read. On mobile devices, I do not think that option is available for you, add a trend line, for some reason. There may be a way to do it. You might have to find a solution online, but as far as I know, you might not be able to do it with a mobile device. I will show you how to calculate that in just a second. But from here, using the desktop version, we are now complete. We have our table with our two variables and the data, the numbers, and we've created our graph that has a title, that has the axes labeled, it has the data on it, and it has a line of best fit with an equation. This is all you need to do to submit an appropriate graph in a science course. If you're using the desktop version, you're done now. But let's take a look at the mobile device options for calculating the equation. In this example, we see that the value for our x variable is 0 when our y variable is also 0. This means that the y-intercept of this equation is equal to 0. Hence, the equation that we have on the chart, on the graph, has no x-intercept. It's not 5.9, it is not 5.9x plus or minus some other number. The general formula for the equation of a line is y equals mx plus b, where the letter b is the y-intercept and the letter m is the slope. The program calculated the slope as 5.9. You are used to calculating slopes of straight lines from grade 9 math. But let's take a quick look at how we can use Excel to calculate it for us. What we will end up doing is we will use the formula that slope is equal to the difference in the y values of two y values on the line, so y2 minus y1, and then we will divide that difference by the difference in the respective x values, x2 minus x1. So our first point that we will look at will be x1, y1 in coordinate form. And then the second point will be x2, y2, also in coordinate form. So let's look at the first point that we're going to do. It'll be further to the left. Let's say an x value of about 1.5. We start at 1.5 and we move our way up until we meet the line. Then from here, we move it to the left and try and see roughly where we meet the y-axis. This looks to me to be about, let's just call it, why not 8.5? So when we have an x value of 1.5, we approximately have a y value of 8.5. Then let's take a look at another point. Why don't we look at an x value of 3.5? Again, starting at 3.5 and following this vertical line up until we reach our trend line, then we move across to the left and see roughly, I've moved my mouse, roughly where it meets the y-axis. We are a little bit above 20. So why don't we call this 20.5? And we have our two coordinates, 1.5 and 8.5, 3.5 and 20.5. We can input these values by saying that x1 is 1.5, our y1 is 8.5 here, our x2 3.5, y2 20.5. We know that the equation is asking for the differences in the y's divided by the differences in x. We don't need to grab a calculator. We don't need to grab pen or pencil. We just put an equal sign into an empty cell. This indicates to the program that I want to do some math. So I can use symbols on my keyboard to represent mathematical operators to do math. Let's say I wanted to find out the sum of 2 plus 5. I would type equal sign, number 2, plus sign, number 5. I hit enter, and it computes the value, the number 7. I can see my equation I typed in the editor bar just underneath the ribbon at the top of the screen. And I can modify numbers as I need to. If I did not want to find the sum of 2 plus 5, I could find the sum of 2 plus 8. I could hit enter, and it would tell me the new sum, the value of 10. I can also do more complicated calculations using numbers already entered into my spreadsheet. My equal sign is still there, but I want to calculate the difference in the y values. So I enter a bracket, and I would select my y2 value first. So I select the 20.5 cell. I then put a dash, which represents a minus sign. And then I would select the value for y number 1. Notice it's cell C42 and cell C40, the blue and the red number. I close that bracket. I then put a forward slash to indicate a division, and I add another bracket where I will subtract the x value minus dash the x1 value. So notice that they are now purple and green, and I close my bracket. You can hopefully see how the equation I've entered with the equal sign is identical to the equation I put in cell B35. y2 minus y1 divided by x2 minus x1. Hit equals, and it computes the number 6. This is my slope, number 6. Very close to what the computer calculated as 5.9. We are a little bit off because we were estimating some of these values, but we are not far off, which means we've done a good job. Therefore, I could write my equation as, y equals 6x. And then I would have my equation, and I could put that on the graph or wherever I needed to. If you cannot calculate, if Excel does not automatically calculate this equation for you, you can simply do it by hand, quote unquote by hand, like this. And you can see how you can use Excel to enter equations to do it for you. From here, if I wanted to now save this and export this and perhaps upload it to the LMS, email it to someone, a good way to do that would be to go to the File menu. I know that, sorry, you can't see it on my screen right now, but clicking the File menu, you can see a bunch of new options here. New from template. If you select Save a Copy, right, if you might already have autosave enabled, which means that every change you make is automatically saved. But I want to make a new copy of this, so I would select Save a Copy. A new dialog box shows up, and I have some options of where I want to save it on my computer. I can change the title of the book, of the Excel file. But what's more important is to select the file format. Notice that it says Excel workbook, which is what is the current file type I'm working with. If I save this as an Excel workbook and upload it to the LMS, then the teacher would see what we're seeing right now. Would see a bunch of cells, equations. It would open up Excel on their computer. They would see that. That's not always ideal because sometimes formatting can change, especially between devices, and the size of the file could also be restrictive. A better choice is to select PDF. This will save my file as a PDF now. Much more versatile when working with digital tools and online, especially when uploading to LMS. This will ensure that none of my formatting gets changed. Everything that I've saved it should look the way I want it to. We can select the entire workbook, which we don't need. The entire workbook would be saving this tab, my Physics 11, the Cohort A, Sheet 2. It would save all of that as a PDF. If I select Sheet, the only thing that will be saved as a PDF is my distance versus time graphs, the currently opened sheet. I could then click Save, and I would now have a PDF version of what I'm working on, ready to be emailed or exported or sent anywhere I need to. You should only be doing this when you are very sure that everything has been completed. Because if you need to make a change into the workbook, you will have to make a change and then save a new file. That's it for our tutorial of how to use Microsoft Excel. So to summarize, we know how to enter data. We enter data just using our keyboard. We know how to make a graph using the commands found in the ribbon or on the right-hand side of the screen. We know how to add a trend line to the graph. We know how to add an equation to the graph. And we also have learned how to use the program, Microsoft Excel, to do calculations for us. We can use it as a calculator. And then we also know how to export all of our work as a PDF file, very easy to share online. You can try it yourself now. Use the exact same data that I have here, and I want you to create your own graph. Also to mention is that this graph can now be copied and pasted into other programs. I can open up Microsoft Word and I could put this graph in a Word document, and I could then write text, answer questions, provide commentary on my graph if I needed to. And then I could also then save my Microsoft Word document as a PDF. So I can combine a text document with a graph that I've made in another program. Hopefully you found this helpful. Good luck when you try it on your own.